So we are continuing section 2.6. We are going to prove statements about segments and angles. Here are our keys to writing a 2-column proof. The first is going to be to copy or draw the diagram and label information to help develop proofs. Okay, if the diagram is in the book, I would copy it down on your homework paper. On a quiz or a test in here, obviously the diagram will already be there for you, but we should still mark it with any information that we need. The number of steps will vary by problem. Okay, it will not always be the same number of steps. It could also vary with how you approach it. So 2 people could do the same proof, both of them get it right, and it be done in a different number of steps. Statements are based on facts that you know or conclusions from deductive reasoning. Okay, each reason must correspond with the statement. That's why we number them, so we know which ones correspond to each other. Definitions, postulates, or proven theorems are used as reasons. We also use properties. We've done that a lot. The addition property, reflexive property, transitive property. We will also use definitions and postulates. We've used some of those. Definition of congruence, angle addition postulate, segment addition postulate. Or if you have proven a theorem already within your proof, then you can use that moving forward. Questions, concerns? Anybody need more time? Okay. So today's examples are just some proofs. Some of them will be pretty short. Some of them will be a little bit longer. In my opinion, this one should be really short. Okay, we should be setting up 2-column statements and reasons. I believe yours are already set up for you. Statements, reasons. Make sure you are numbering them as you go, because I need to know what statement corresponds to what reason. The first statement that we should always make should come from where? The given information. So they only gave us one piece of information. What is it? Good. Segment AB is congruent to segment CD. What's our reason for that? It was given. Oop, that should still be a 1. Given. All right, number 2. Yep, this one's really short. Segment CD is congruent to what? Segment AB. What property allows us to do that? Good. Symmetric property of congruence. You could just write symmetric. There are some things that we can shorten, but we should not be abbreviating everything. So the words symmetric, reflexive, transitive, all of those words, I expect you to just write them out. Anything else that we need to do? No, why not? Okay, that was already our proof statement. That's how we know that we're done. We reached our proof statement. Adriana? Right, you've got to give a reason for why that's proven. We'll never actually write the word prove. That's what they're telling us to do. They're telling us we need to prove this. We have to give a reason why it is proven. Other questions? Ready for another one? Okay, next one is not going to be 2 steps. However, we have done one similar to this before. Okay, your diagram is already there for you, as is your 2-column statements, reasons. You should be able to go ahead and start this because your first statement should be what? The given statement. So what did they give us this time? Good. Ray BD bisects angle ABC. Our reason, of course, is given. They had to give us some information to start with. Our next statement needs to be based on that given information or based on the diagram. I tell you, what do you think?
ABC equals angle 1 measure at angle 1 is equal to
Good. So that doesn't deal with our given, but that's okay. We can come back to it. We are going to need to talk about angle ABC. So the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. What allows us to say that? Very good. Angle addition postulate. If you put angle add, that's fine. The angle addition postulate lets us add 2 small angles together to get a bigger angle. Okay, at this point we probably do need to go back to that given information and write another statement about what we know because of that. What do you think, Akira?
The angle ABC is equal to angle ABD plus DBC.
That would be the equivalent of what Atea said. She just called them 1 and 2 instead of naming them by their angles. So you're not wrong, but we wouldn't want to make the same statement twice. Majay, what do you think?
Would it be measure of angle 1 equals measure of angle 2?
Good. We would know that the measure of angle 1 and 2 should be equal to each other. How do we know that? Or why did we say that? What do you think, Atea?
because it because they said it's equal.
Good. So that's the definition of a bisector. That would be how we would state our reason. Because we had a bisector, that's how we knew that. So definition of bisect. To bisect means to split it into 2 equal or congruent parts. Do we have questions about that? That's a new one that we haven't used before. Okay, anytime they give you a word in a given like bisect or parallel, perpendicular, any of those vocab words, congruent, it's very often that we will use the definition of one of those special key words later in our proof. All right, where do we go next? Kara?
So we'll go back to that set number 2.
Mm-hmm.
The measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 1.
Beautiful. Why?
Substitution.
Very good. We substituted in the information that we knew from step 3 into step 2. Substitution. We replaced the measure of angle 2 with the measure of angle 1 because they were congruent or equal. Yes, ma'am.
And then we write down the proof.
Yes, now we're ready for our proof statement. We are at the end. So we can now say the measure of angle ABC is equal to 2 times the measure of angle 1. What allows us to say that? Simplify or combine like terms. Questions, concerns about our proof? Okay, this was not the only order that we could have done it in. We would have needed all of these statements and reasons at some point. Okay, but it's possible that some people would have rearranged some of these steps, and that would have been fine. All right, how many givens do we have for number 3?
2.
2 of them. They gave us 2 different givens. Personally, I like to list all my givens first. That's how I was taught to do it 14, however many years ago. Some people prefer to not give a given until they need to use it. It doesn't matter to me. But at some point throughout your proof, you should be writing down both of the givens. So, my step 1 is going to say that R is the midpoint. I'm fine with you shortening midpoint to MDPT, midpoint of segment AM. My second statement would be that MB is equal to AR. My reason for both of those is going to be given. Okay, something else that I was taught, but I doubt you'll see in the book, is to put these little quotation marks there. That just means, right, ditto, same thing, so they're both given. If you don't like that, that's fine. If you do, go for it. But this is going to refer to directly above it. So don't put those little quote marks unless you mean the same exact reason from just above it. Ariane.
Can you put step 1, step 2, all in step?
Yes, you can, and I would be okay with that. I like to separate things out in case I have to refer back to them, but yes. If you put it like a comma or a semicolon here and wrote that and just did it all in one step for your given, that's fine. I believe usually textbooks and worksheets will separate them. So I just try to show you how you'll see it most often. Okay, so we're off to a good start. We've already got 2 steps down. It might help us to mark what they told us in the diagram. So they definitely told us that MB is equal to AR. Could mark MB and AR each with a tick mark. I do want to revisit, though, my very first given. R is the midpoint of segment AM. What does that mean to us? What does it mean to have a midpoint? It's in the middle. Kara, what do you think?
It means that AR and then RM are congruent.
Very good. So we could say congruent, but because they're using equality, I would stick with that so we don't have to switch back and forth. So yes, it means that they are congruent or that they are equal in measure. So AR is equal to RM. What definition did we use there? Midpoint. Definition of midpoint. So like I said on that last one, anytime you see what we would have had as a vocab word at some point, you're probably going to need to use its definition somewhere along the way. Okay? Now, if we look at steps 2 and 3, think about what property that we've learned recently we could apply to that and a statement we could make from steps 2 and 3 put together. Majay, what are you thinking?
RM equals MB.
Sure, RM equals MB. I'm going to go in the order we have them. I'm going to put MB equals RM. Of course, we know that's the same thing. So step 4, MB is equal to RM. Okay, we know that if this is the midpoint here at R, there it is, then those two have to be the same, and they already told us AR and MB have to be the same, so all 3 of them really are going to be equal to each other. What property did Majay use to make that, Akira? Very good. The transitive property allows us to say that. Transitive property lets us say that those are equal by cutting out AR, which was in the middle there. Now, if on step 3 we had said RM is equal to AR, we would have had to throw another step in there, flipping it around using the symmetric property. Does that make sense? Okay, so we need the AR to come at the end here and at the beginning here in order to use transitive. We have to pay attention to those small details. Okay? Next up, anybody think they know what we should do? What do you think, Kara? Yes, we are now at our proof statement. We have enough information to say that M is the midpoint of segment RB. Why do you think we're allowed to say that? What do you think, Ariana?
You already said that, you already stated that RM is equal to RB, or NB is equal to RM, so it's saying that.
So what definition are we using again? Midpoint. We're using the definition of a midpoint again. Now I'm not going to put quotation marks because there's a different step right above it. Okay, even though I used it up here, I can't put my little quote marks because there's something separating it.